Welcome to this short introduction of the Scientific Graphic Organizer for Practical Work. My name is Freek Pols. I'm a former secondary school physics teacher and now coordinator of the first year physics lab course at Delft University of Technology. In physics, students often engage in small classroom experiments, often referred to as practical work. Practical work is conducted for various goals: for linking theory with practice, teaching how to engage in inquiry, learn to work with complex but accurate equipment, and so on. After students conducted the activity, we want to know how well they did. There needs to be some kind of assessment. In assessing, most of the time we want to know whether students did what was intended, and whether the learning goals were attained, whether they learned what was intended. The established way is to have students write a report. Students spend valuable time on writing a report, often unsure what to write and how to write it. It also increases the teacher's workload, with reports piling up to be graded. But more importantly, reports hardly allow to infer what the students have learned and which skills are mastered, as especially students' ability to communicate is assessed. In other words, there is no constructive alignment between what we want students to learn and how we assess it. To overcome these problems, I developed the Scientific Graphic Organizer, or SGO. The SGO can be regarded as a pre-structured lab journal consisting of 2 pages. The SGO provides a schematic for reporting the essentials of an inquiry: the research question, the chosen instruments and method, theory used, data displayed in tables and graphs, a conclusion, the argumentation supporting the conclusion, and a critical evaluation. As a teacher, a quick look at this SGO provides valuable information on whether students understood the task, what they precisely did and found, and whether their conclusion is correct. It also provides students help with writing their reports. All essential information is already in the SGO. By providing information in the cells, one can replace the worksheet. Providing more information makes the task more guided. Intentionally leaving cells opens up the practical. The SGO has proven to be a useful instrument for research as well. In the paper, Would You Dare to Jump? Fostering a Scientific Approach to Secondary Physics Inquiry, published in the International Journal of Science Education, the SGO is used to monitor students' approach to their inquiry, revealing, for example, how many repeated readings students took. The SGO provided valuable information in determining students' understanding of doing inquiry. To conclude, the SGO is a useful tool for students, teachers, and researchers. It provides all essential information to produce a fair judgment of the attainment of the learning goals without the necessity to write an extensive lab report.